Okay, so this is going to be the first unit in learning about quadratic functions, okay? So a quadratic function, when we graph it, it's in the shape of a parabola, okay? So a parabola either looks like this, facing upward, okay? Or it can be over here, facing downward, okay? So quadratics are different than what we've learned before, okay? Which was a linear equation. And we knew that a linear equation was a straight line. Okay, so now in quadratics, we're going to be graphing something called a parabola. Okay, so let's take a look at the first couple examples. Okay, so here what we want to do is choose values for x to plug into the equation and out comes y. Okay, so something that we're used to, we're going to make a table and then we're going to graph each equation. Okay, so looking at number 1, I'm going to choose values starting with -3. So -3, -2, -1, 0, 1, 2, and 3. Okay? So I'm choosing my domain, which is my x value. So I can say that the domain can be any real number. Okay? So here the domain is all real numbers. And then what I'm going to do here is plug in -3. So I'm plugging in -3 for x, and then here I see it's squared. Okay, so -3 squared is 9. Let me use a different color. Okay, the next one I did -2 squared, which is 4. -1 squared, which is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. Okay, this first one up here was a 9 also. Okay, so now I can graph my 2 points. For example, this would be my first point. X is -3 and y is 9. Okay, so I'm going to graph on my coordinate plane. Okay, so -3, 9. Let me see, 1, 2. Okay, then the next point is -2, 4. -1, 1. 0, 0. 1, 1, 2, 4, and 3, 9. Okay, so I can see that when I connect, these, I have a parabola facing up. Okay, so the range, if I look at the range, all the y values that are over here. Okay. All of these values, and you can see on the graph here too, are above 0 on the y. Okay, so nothing is a negative y. So the range for y is that all the y numbers have to be greater than or equal to 0. Okay, they could be 0. I have a 0 right here, but then the rest of them are facing up. Okay, let's do one more of these together. And let's look at number 3. Okay, so here on number 3, I'm going to use the same values. I'm going to plug in -3, -2, -1, 0, 1, 2, 3. Okay, so again, because I was able to choose all of the domains, again, it's going to be all real numbers. All right. Plugging in, I have x, which is -3. So -3 squared minus 7 is going to give me 2. Next one, -2, plugging in -2. -2 squared minus 7 is -3. -1 squared minus 7 is -6. 0 squared minus 7, -7. 1 squared minus 7 is negative 6. And 2 squared minus 7, negative 3. 3 squared minus 7 is 2. Okay, so now I can go ahead and graph my points. My first point is negative 3, 2. Okay, so I'm going to find negative 3, 2. Let me erase this part right here. Okay, negative 2, negative 3. Negative 1, negative 6. Zero, negative 7. One, negative 6. 2, negative 3. And 3, 2. Okay, so you can see that these points are reflected over the y-axis. Okay, so it's kind of like a mirror. Whatever is on the left side is also on the right. So if I connect here, I get a parabola. Okay, and then my point where it hits the y-axis down here is at 0, negative 7. Okay, so I know that everything here and above is everything that y could be, okay? Because the parabola is opening up, it can't be anything that is down here, okay? So I can say that all the y values are greater than or equal to negative 7, okay? Because it is negative 7 here, and then everything above would be what the y values are, okay? So for right now, I'd like you to pause the video and try numbers 2, 4, 5, and 6 on your own, okay? And then I will give you the answer key to check these. So you can use the same domain values of negative 3, negative 2, negative 1, 0, 1, 2, 3, just like I did, okay? And see what you can come up with.